record. Okay. Okay, then I start to share the screen. Okay, come back to this. Right. Should be recording now. Let me see. Okay, right. Okay, we come back here. A and B, there are 2 points on the curve, on the blue line. And I also join these 2 points using a straight line. So the straight line is red color. Okay. Now, this red color line, since it intersects the blue curve at 2 points, then this red line is known as a chord. Okay, known as a chord. And if I move this point B towards A, and you see when I move this point, the numbers there, they all change. Okay, so as this B approaches A, delta X and delta Y approaches 0. Okay, delta X approaches 0, delta Y approaches 0. So we move it, it continues to be a chord. This line AB is still a chord. So when it is so close to this point A, it will become a tangent. Can you see now the red line looks like a tangent? So far, any question? Any question? I should look here, not look there.
No.
This, your faces are all here, but my face is there, so I look there. Any question? So far, any question?
No. No, sir.
No, no. So you understand that
No.
initially this point B is quite close to A. And I make this point B approach A. So when it is quite near to A, the line AB is no longer a chord. And you can see physically that the line AB is actually a tangent. Tangent to the curve, the blue curve at the point A. Okay, so let me show you the picture. So at first it is like this. The 2 points A and B, they are quite far apart. And later, when delta X and delta Y approach 0, it become a tangent. Okay, you can see clearly it looks like a tangent already. Okay, now what does this mean? Okay, this means that as delta X approaches 0, delta Y over delta X approaches dy over dx. Now here I can write delta Y delta X, but over here I cannot write delta Y delta X. Okay, so here I write delta Y over delta X. So as delta X approaches 0, delta Y over delta X approaches dy dx. So this is actually the definition of dy dx. This is actually what we learned last year, the first principle, differentiation from the first principle. Okay, but mathematically it is like this. But in graphically, what does it mean? Graphically, it means that my dy dx is the gradient of tangent at the point xy. So I stop, I pause a while. So any question? The dy dx graphically is actually the gradient of tangent at the point xy. No question, I will continue. Any question? No, no, then I will continue.
No.
No, I continue. And the gradient is actually shown here. I have calculated all this. I think I gave you all last year this program, geometer sketchpad. Anyone still has this program? If you have this program, I send you this file, you can actually open up the file. But if you don't have this program, then I send you the file, also no use, and you cannot open the file. Okay, right. So far, what I want you to know is this. dy dx is the gradient of tangent. If it's okay, then I move on. Okay, move on. Next. So the formula and the facts that you need to know, I've written at the top left-hand corner. Can you see the blue words? Okay. So these blue words here, they will guide, they will help you lah. They're actually hints for you to solve this problem. Okay. Right. So we start. Find the gradient of tangent to each of the following curves at the given point. So what does that mean? It means that this equation y is actually the equation of a curve. And they want you to find the gradient of tangent to this curve at the point x equals to 1. Okay, what must we do? What must we do? You see this? They say if you want to find gradient, you have to find dy dx. So let us find dy dx. Okay, y equals to x squared plus 3x minus 4. Can you still remember how to differentiate? Can. Okay, so differentiate x squared is 2x. Differentiate 3x is 3. Now you see this dy dx is actually a variable. There's a variable there, x. There's a variable there. So we cannot know what is the value of the gradient. The value of the gradient depends on x. It means that if I put in different values of x, I will get different gradient, which means that at different points along the curve, I will get different gradient. Okay or not? Okay, not, then we come back here. Right. So let's say we have at the point A here, the gradient of this of this red line has a certain value. If I choose another point somewhere here, the gradient will have a different value. Now that is the reason why the gradient depends on x. So let's say I want to know what is the gradient at this point x equals to 1. I need to substitute x equals to 1 inside the dy dx. So when I substitute x equals to 1 inside the dy dx, I get dy dx equals to 5. What is the meaning of dy dx? dy dx means gradient of tangent, right? So gradient of tangent at this point, 1, 0 is 5. Okay, pause. Any question? Anything you want to ask, Salwa? I remember you, Salwa. No, no question. You already mute your mic.
No.
Don't want to talk to me. Okay, right. Anybody else? Let me see. Wow, so many not talking one. Karen is talking. Li Ying not talking. Sharifah no not talking. Kanisha all not talking. So far, no question. Okay. Balprit also here. Nuru Azra. Okay, I remember all this. Parish, all I know. Okay, right. So if you have no question, then we continue with the question A. Now, all these questions, A, B, C, D, E, they are all inside your Google.
Google Classroom.
Let me transfer to Google. Transfer to Google. Okay, right. Now, all these questions, they are inside your assignment. Okay, where's your assignment? Yeah, here. So we click on the assignment. Okay, we click on this. Yeah, so they are all here. They are the same question. After I've shown you what to do, I hope you can practice this on your own. You can practice on your own. Can or not? Can, can. Okay, so this is your assignment. We go back to our geometer sketchpad. Okay, come back to our geometer sketchpad. We look at question number one, question A. Right? What must we do when you look at this equation? This topic is about differentiation. Oh, YB Chiam. Good day, YB Chiam. Parish Sharifano. Okay. we have this equation. This topic is about differentiation. So whether you know or you don't know how to do the question, you just differentiate. Marks will be given, at least 1 mark, that you know how to differentiate, you'll get 1 mark. So how many of you still remember how to differentiate? This is 4x plus 6. Yeah, dy dx is 4x plus 6. Can you tell me why the dy dx has a variable x there? Anyone can tell me? Megan, you were here just now. Why is it that dy dx has a variable there?
Because x squared
Salbanika, Galaxy Pro 9. I don't know these people. Maybe next time I must give password, then only they come in. I don't know, maybe some strangers, then they just hack into our group. Then you see Galaxy Pro 9. You didn't use your own name. Okay, right. Never mind, Megan. It has the x there because different values of x, that means different points. Different points, that means the gradient is different. Okay? Okay. So when at the point x equals to 1, I have to put in 1 to get the actual value of the gradient. So when you substitute x equals to 1, the gradient is 10, the dy dx is 10, which means that the gradient at the point x equals to 1 is 10. Okay, next. So you look at this function or this equation here. Y equals to 2x plus 1, x squared minus 3. Okay. This is a problem about this problem is about differentiation, so I need to differentiate. Now, can anyone tell me why is this differentiation different from the previous one? What must we use to differentiate this function? Anyone? With all the 3 classes.
product.
Yes, product rule. Because this is, we have 2 bracket here. It is the product of two terms here. So we use the product rule. You still remember how to use the product rule? If not, then I go through with you again how to use the product rule. Okay, so I go through with you again how to use the product rule. We have 2 bracket here. You differentiate the first bracket and keep the second bracket. So when you differentiate the first bracket, you have 2. Keep the second bracket, x squared minus 3. After that, plus, just now you differentiate this. Now you keep this bracket, the first bracket, and you differentiate the second bracket. So keep the first bracket, 2x plus 1. Differentiate the second bracket, 2x. Okay. So this is dy dx. Now, actually, you can simplify this expression, but it is not necessary. Waste a lot of time. So straight away I substitute x equals to -1. Okay, I substitute x equals to -1 into the expression. So when you substitute x equals to -1, -1 square is positive. Right? Then -1 times 2 is -2. -1 times 2 is -2. So what you have here now, dy dx has a value of -2. So dy dx is no longer an expression. It's no longer an expression involving x. It is a value, right? When you substitute in a particular value, dy dx takes a value. So this value is actually the gradient of the tangent at that point. So therefore, gradient of tangent at that point, -1, 2 is -3. Why is this question C different from the others? Anyone? Why is it different? About Brit, why is it different? YB Chiam, why is it different? Hey, Nurul Iman, congratulations, you can log in now. You were telling me cannot do, must need password and so on. Okay, right. Can anyone tell me why C is different from the others? You must use what rule, Sabanika?
We have to use quotient rule.
Yes, you have to use quotient rule. Thank you. So we are going to use quotient rule. Now this is how I'm going to use the quotient rule. This is how I'm going to use the quotient rule. Now the quotient rule in this function, it has two parts. The top one is the numerator and the bottom is the denominator. So I always start, not I, you must always start with the numerator, that means the top one. Differentiate the top, you have this number 5 here. You differentiate the top, you have this number 5. And the bottom, you just keep the x square, you just keep. So that's how I get the first term here. The second one, you keep the top, that is, you have to keep the numerator and you differentiate the denominator. So keep this, differentiate denominator, x square is 2x. Then the whole thing divided by the denominator square. This is x square, the denominator is x square. Denominator square is x square square. Because this one looks very ugly, we need to simplify it a bit. Don't substitute in the point here. Need to simplify it. So it expand and simplify. Trisha, remember I asked you to do this every morning last year. All the papers I asked you how to simplify algebraic expression. And okay. So you simplify the algebraic expression, you expand and simplify. So finally you get negative 5x squared plus 4x divided by x to the power 4. Now it's very simple. You can substitute in the point. Where is the point? The point is x equals to 2. So you substitute in x equals to 2, you have negative 12 over 16, that is negative 3 over 4. So finally, gradient of tangent at the point 2, 2 is negative 3 over 4. So what we have been doing so far, we try to find the dy dx. Why must we find dy dx? Because dy dx is the gradient of tangent. Dy dx is the gradient of tangent. So as soon as you find the dy dx, you substitute in a particular value, you will get the actual value of the gradient. Any questions so far? Is my voice clear or not?
Yes.
Yes. Any questions so far? So many of you already. I don't know how many. I have to check and
No
see how many.
question.
Participant 26. Oh, very good. 26. Yeah. So I open up this. So I have altogether 26 participants. Oh, 26 participants. Okay, right. No question, then I will move on to another part. How to find the equation. Now, please take note that whatever you need to know, I summarize it at the top left-hand corner. Okay, this is what you should know. Okay, next. If you look at the top left-hand corner, I have written 3 different colors there. Can you see the 3 different colors? These are the 3 things that you need to know in order to solve the problems here. Okay, right. What the first thing is dy dx is the gradient of tangent. First thing you must know. Second one, you must recall from our coordinate geometry to find the equation of a straight line y minus y1 equals to mx minus x1. This is how we're going to find the equation of a straight line. And the third thing you need to know is the gradient of two perpendicular lines. If M1 and M2, they are two gradients of two perpendicular lines, then the relationship between M1 and M2 is like this. M2 equals to negative 1 over M1. Okay, so these are the three things that you need to know. Question. Find the equation of tangent and normal to each of the following curves at a specific point. What they want you to find. Okay, so we go back to the graph. So the equation of the curve is the blue line. The equation of the tangent is the red line. So what they want us to find now is not only the gradient of this red line, but you also need to find the equation of this straight line. Okay, that's what they want you to find. So back, okay. So how to find the equation of tangent and equation of normal? So this is the first problem I'm going to solve. Y equals to x squared minus 4x plus 5. So what must you do? Differentiate. Differentiate, find the gradient. Okay, differentiate and find the gradient. So differentiate, you get dy dx equals to, oh, suddenly you unmute your Zoom. Huh? Okay, dy dx is 2x minus 4. So this is the gradient function. But you want to find a particular value, you have to substitute a point inside. So substitute a point inside, dy dx equals to negative 2. Now this time, I call the value of dy dx m1. Do you know why I want to call it m1 or not? Why I need to call it m1? Why I need to call it m1?
Because we want to find the normal.
Yes, because I want to find the normal. I want to make the normal different from the tangent. So this is the gradient of tangent, I call it m1. Gradient of normal, I will call it m2. So I just give it a different name. Okay, so after finding the gradient of tangent, and I also know the point, 2, 1. This 2, 1 is given. I just quote from the top. It's nothing new. It's just from the top I copy down. I quote from the top. Knowing the gradient and the point, can you find the equation of tangent? Yes, right? You use this formula. Formula. Use this formula. You use this formula, you substitute in the gradient of tangent, you substitute in the point, the coordinates of the point, and you simplify, you will get this. Okay, so far, so good. Give you some time to digest. If you have question to ask, just ask. Okay, no question. So no question, we proceed. Next, we have to find the equation of normal. What we have been doing so far is finding the equation of tangent. Find the gradient of tangent, find the equation of tangent. Right. So now, to find the gradient of normal, if you want to find equation of normal, you have to start with gradient of normal. To find the gradient of normal, I call the gradient of normal m2. So m2 equals to negative 1 over m1. So from there you can find the gradient of normal. Hey, Hari Dashini, why you go and chontang the screen? Okay, so this M2 you cannot find from differentiation. The M2 you find from M1. How to find M2 from M1? You just find the reciprocal of M1 and you change the sign. That will be the M2. Okay, find the reciprocal of M1, Change the sign, you get M2. So knowing M2, the gradient of normal and the point, can you find the equation of normal? Knowing the gradient and the point, the coordinates of the point, can you find the equation? Yes. So again, you use the same formula. Y1, y minus y1 equals to mx minus x1. And you substitute inside the equation, the formula, and you will get the equation of normal. Right. So far, any question? Another few seconds.
No,
Yes. What's your question? No, no question.
no
Everybody
question.
mute like that. You already what? Tape up your mouth, don't want to talk. You have made up your mind not to talk already. You just mute like that. Salbanika Vishalini. Chiam Yit Bei. Sai Karin. Okay, right. So if no, then I show you one more example. One more example. This one, the A, example A. For A, we have a curve, equation of the curve. So equation of the curve is x squared plus 3x minus 5. So I copy it over here. And the point on the curve is 1, -1. So we are supposed to find the equation of tangent and normal to the curve at this point, 1, -1. How to start? How to start? So we start by finding dy dx, correct? Thank you. So we start by finding dy dx. This function is very easy. It's a polynomial, a second degree polynomial, very easy to differentiate. So we have 2x plus 3. So after finding the dy dx, you have to find the value itself. Okay. So the value, we have to substitute in the point 1. So substitute in the point 1 and we get the value is 5. Again, this time the value I call it m1 to denote the tangent, to make it different from the normal. Otherwise you get confused, right? This one also m, that one also m, and you get confused. So tangent, I call it m1. Normal, I call it m. So the value of m1 is obtained by substituting 1 into dy dx. So the value of m1 is 5, which means that the gradient of tangent is 5. And again, point is 1, -1. Making use of the gradient and the point, can we find the equation of tangent? Yes. Just substitute inside. Equation of tangent. 5, substitute in 5. 1, you substitute in 1. -1, you substitute in -1. Simplify, you get y equals to 5x minus 6. So this is the equation of tangent. Then we go on to equation of normal. Before you find the equation of normal, you have to find the gradient of normal. How to find the gradient of normal? Find the reciprocal of m1. The reciprocal of m1 or the inverse of m1 is m2. But of course, you need to change the sign. After you inverse it, you need to find change the sign. So 5 become -1 over 5. To find the equation of normal, you need both the point and the gradient. The point and the gradient. And substitute these two things inside the same formula. y minus y1 equals to mx minus x1. Okay, so you get the correct answer. X plus 5y plus 4 equals to 0. So Liu Ying got all correct except the next question, the last question. Any question before I move on to the next example? Salwa, got question
Sir,
or not?
sir.
Yes.
So what about
No.
if, if the question asks for parallel lines?
Parallel lines. Parallel to the normal and so on. That one is the reverse. They give you the gradient, you find the point. Okay, now because we are just starting, I cannot ask you to do the reverse process yet. Okay, probably after this, then we go on to the more difficult question. They will give you parallel lines, correct? They will give you parallel lines and you can obtain the gradient from that line and equate the gradient with dy dx. When you equate gradient with dy dx, you'll find the value of x. If you know the value of x, that means you know the point. So actually they want you to find the point. Okay. Any more question?
Okay, sir. Thank you,
Okay.
sir.
If not, then carry on. Okay, next one. So
Okay.
again, I summarize what you need to know on the top left-hand corner. So these are the three things that you need to know. These are the three things that you need to know. Question. Okay. So the question, you are given the curve, the equation of the curve, and the point. Now, please take note that you are only given the x coordinate. You are not given the y coordinate. So when you want to substitute into the equation of the straight line, can or cannot? Cannot lah, because you don't know the y coordinate. So you better start by finding the y coordinate because they just give you the x coordinate only. Can you see the problem or not? In this question, you are only given the curve and the x coordinate. So with the x coordinate alone, you cannot find the equation of the line. You need to know the y coordinate. Okay, so we start by finding the y coordinate. Okay. Oh, this one very ugly because of the big dot there. Okay, never mind. So I use this value x equals to 2. I substitute into the y. Don't substitute into dy dx yet. Substitute into y. So substitute into y, simplify, and you can find the y coordinate. You get the value y equals to 1. So what is the point? The point is 2, 1. 2, 1. Okay, find the point first. And now, after knowing the point, we can proceed to find the gradient. How to find the gradient? Find dy dx. Okay, find dy dx. Now, to find dy dx, you cannot use product rule or quotient rule. This one you have to use the chain rule. This is function of a function. You use chain rule. Okay, so how to use the chain rule? Differentiate. Huh? So first of all, you take these 2, you put in front. 2 put in front. Then the bracket, you keep this bracket. But 2 less by 1 become 1. Okay. After that, you differentiate inside the bracket, you get 4x. Can you still remember how to differentiate function of a function? Nurul Iman. Better lah. You come to this class, you don't talk with other girls. Very good. If you are in class, you want to talk to other people, you turn back, turn around and talk. Now you want to turn around, you talk to your brother and sisters. Nurul Iman, Nurul Iman. Okay, very good. You come to this type of class, you cannot talk with your friends. You have to pay attention all the time. Okay, right. So you still remember how to differentiate function of a function, right? Differentiate the power first, then differentiate inside the bracket. So we have this expression, 8x bracket 2x squared minus 7. So this is the gradient function. So the point is 2, 1. So I substitute 2 into the gradient function. Another name for dy dx is the gradient function. When you're dealing with equation of tangent and equation of normal, probably they will tell you dy dx is the gradient function. That's another name for dy dx. Okay, so substitute x equals to 2 into the gradient function dy dx, you get 16, which means that the gradient of tangent is 16. The gradient of tangent is 16. At this point, 2, x equals to 2. So knowing the point and the gradient, can you find the equation of tangent? Yes. So I summarize here. Point, this is, I just quote from the top above, quote from above. The point is 2, 1. The gradient of tangent M1 is 16. So making use of these two, the point and the gradient, substitute into the equation, you can find the equation of tangent. This part, Liu Ying is still correct. Is still correct. Okay, so you find the, next we are going to proceed to find the equation of normal. To find the equation of normal, you have to find the gradient of normal first. So the point is 2, 1. Again, this is still the same point, 2, 1, right? But the M2, normal is M2. So how to find M2? You take the value of M1, inverse it, change the sign, you have this M2. Knowing the equation of, knowing the point and the gradient, you substitute into the formula and find the equation of the normal. Okay. So Liu Ying, you better see what's wrong with your point and your gradient, this part C. So far, I checked this one different. Your answer is different. Liu Ying, Liu Ying. Where are you, Liu Ying? Let me see. Still here or not? Offline or online? Ah, yes, still here. This one is Liu Ying. Okay. So, yeah. Because you are only given the x coordinate, you have to find the y coordinate by substituting x into the function y. So when substitute x into y, you find the y coordinate. The y coordinate is 6. So the point is 3, 6. So after you have found the point, you have to find the gradient. How to find the gradient? Find dy dx. This is the quotient rule. Okay, quotient rule. Differentiate the top, you get 1. Bottom, you keep. After that, differentiate the bottom, the top, you keep. Then divide by the bottom square. Divide by the bottom square. Okay. Substitute x equals to 3 inside the gradient function. You have dy dx equals to negative 11. So if dy dx, it is m1. That is the gradient of tangent. Okay. So m1 is negative 11. The point is 3, 6. Use the formula, substitute these two inside the equation, inside the formula, and finally you get the equation of tangent. In this one, Liu Ying, your answer is -12. It should be -11. That's why I asked you to do your assignment first before you come lah. If you do your assignment first, then I know I can point out where is your mistake and you can learn very fast. If you didn't do anything, you just come here, you listen, go back, then only you do, can. But nobody to point out where's your mistake. You submit online, I cannot see your working. I can only see your answer. Maybe next assignment I will give you in the form of Word, in the form of Word, Google Word, so that you can actually add in the symbols, the fractions, like what I did here. You can actually type all these symbols. Google Words. If you don't know how to use Google Words to type all these symbols, ask your friend. Okay, so we have found the equation of tangent. Now we proceed to find the normal. Normal, must find the gradient first. Yes, the point is 3, 6. The gradient of normal, you just find the reciprocal and change the sign. So it's 1 over 11. Using the point and the normal, you substitute into the equation, into the formula, and you can find the equation of the tangent. Okay, that's all. Or if you have problem doing this, the second assignment, the more difficult ones, not this one, the more difficult ones, then you put up at the Google Classroom. I can show you next lesson, or I can make a video and I just post it on YouTube, and you can refer to YouTube. Okay. So far, any question before I end this meeting, or I end this virtual classroom? Any question?
No, sir.
No. Samimi, any
No,
question?
sir.
No. Samimi also no question.
No.
Okay. Then no, not this one. How to stop here? Stop video. No, not this one.
Thank you, sir.
Where to do this one? How to do this? Why only 24 participants left? Okay, right. How many of
Thank
you
you,
left?
sir.
26. 26. Okay, any
Bye,
question?
sir.
Anything that we can improve on? You can give me feedback so that I next time will do it better. Sure, we can do better than this, right? Can or cannot?
Okay.
Thanks, sir.
Yeah.
If you have no question, then maybe you can give me feedback from the Google Classroom. You tell me how to do it better, then I'll do it. Okay. So if you have nothing, then you can log out. You can end the meeting, right?